A-Level Paper 2, June 2017. I've got a reaction pathway here and I've got 1-bromopropane making compound J with sodium hydroxide. It says it's aqueous. In cold aqueous, that means it's got water. In cold water, the OH minus, the lone pair of electrons on the O, attacks the delta plus on the C. Remember, the C to Br bond is a polar bond. The Br is electronegative, draws electrons towards itself, and it's got a slight minus, leaving a slight plus, a delta plus on the C. And the lone pairs of electrons from the OH minus in cold water attack that C and bond with that C and make propan-1-ol. The CBr bond breaks and the Br minus comes off. So that's a process called nucleophilic substitution. The OH minus is a nucleophile. It's a lone pair donor. Alternatively, incidentally, if that were warm ethanol, then the OH minus would attack an H from this carbon here. So you go from the Br to the C to the next C, and it attacks an H on here. The OH minus removes that H. The electrons from the CH move in between the two carbons to make a double bond, and the Br comes off as a Br minus. That's a process called elimination, and it would make propene. That's in warm ethanol, but the AQ tells you that it's nucleophilic substitution. The trickiest part, so it's easiest to lose a mark, is that it says displayed formula, so you need to include all of the bonds in between the atoms, including the bond between the O and the H. Name the mechanism for reaction 2. Well, you've got nucleophilic substitution again, and NH3 has got a lone pair of electrons on the N, which again will attack the delta plus on the C, and the CBr bond breaks and the Br comes off. In this mechanism, that would make N plus H3, so it makes CH3, CH2, CH2, N plus CH3, and one of the hydrogens, the bond would break and move on to the N plus to remove the N plus, and H plus would be removed, and you'd make propylamine or 1-aminopropane. So that mechanism again is nucleophilic, because this is an electron pair donor, and it's replacing the Br with an NH2, an amino group, so that's nucleophilic substitution. Condition, well, for ammonia you need excess ammonia. It's tempting to put increased temperature or increased pressure, but with ammonia you need excess ammonia. That's the condition for ammonia. Calculate the mass in grams of propylamine produced from 25.2 grams of 1-bromopropane in reaction 2, assuming a 75% yield. Well, let's work out what the yield would be if it were 100%, and then we can convert it to 75% at the end. 25.2 grams of 1-bromopropane. So what I've got to do first of all is moles is mass divided by mR. I've got to work out the mR of this using a periodic table, and it turns out to be 122.9. Moles is mass divided by mR, so 25.2 grams of this divided by mR, I've got 0.205 moles. I know from my equation, balancing it, then 1 mole of 1-bromopropane makes 1 mole of propylamine, 1 to 1. So if I've only got 0.205 moles of 1-bromopropane, I must make 0.205 moles of propylamine. So it makes 0.25 moles of propylamine. Now, what I could do with doing is working out its MR, so work out the MR of this. I've got a 14 for a nitrogen, 1 for the hydrogens, 12 for the carbons, and it works out as 58. Moles is 0.205 is mass divided by mR, so 0.205 is mass divided by 58. The mass therefore is 0.205 multiplied by, that should say 58, is 12.095 grams. So I should make 12.095 grams of this. I'm only making a 75% yield, 3/4, so I'll multiply it by 75 divided by 100%, I make 9.07 grams. If I look in my question, 25.2 is to 3 significant figures, so I need to make sure that's to 3 significant figures. 9.07 is to 3 significant figures.